All right. Hello and welcome everyone. So we are live right now. I hope I'm audible to all of you. Right. So today we're going to discuss about differential equation, and especially we're going to start to discuss about how to solve a differential equation. For example, if you are given and given differential equation, how to find out that what is the given form of the differential equation, and from that how can you arrive at the conclusion that what is the required function or what is the family of the curves that the differential equation is trying to represent, right? So that will be the motto of this particular class over here, right? I hope you are have done all the homework. So this was the following question that I actually asked all of you to please solve and come for this class. I hope you have done the solutions. I hope you have done the solution for these questions. Please let me know in the live chat. Okay. So please let me know in the live chat if you have done the solution or not. Okay. And if you haven't done the solution, please take a screenshot of this problem and pause the video right at this moment and try to solve these questions. Okay. Because in today's class we are going to move one step further and we are going to discuss about the solution of the required differential equation, right? So today we are not going to do the first step, that is the formation of differential equation. We are going to go to the inverse of it. Okay, so from a given differential equation we'll see how we can arrive at the given family of curves, right? Now again and again I'm telling it, this particular course of differential equation is a first level course, especially targeting the class 12 students and class 11 students who are preparing for the upcoming mains and advanced examination or any other competitive examination where the syllabus of the examination is very similar to that of the JEE Mains and Advanced examination, right? So our scope of this study over here is to see the solution of ordinary differential equation and also of first order, right? First order ordinary differential equation of first 1 degree. Okay, so that is all what we're going to discuss in this particular lecture, right? So let's get started. Now before I start with this particular lecture, I actually want to take a few questions to actually help you understand that how we can actually solve these problems of formulation of differential equation, right? So let's try to understand one from one very simple example. So I hope if you can try all this question to actually understand how to form the differential equation, but still I will take one more question, right? So there are certain types of question where the family of curve is not directly given. So they will say to find the to find the differential to find the differential equation to find the equation of all to find the differential equation of all circles touching touching the x-axis at origin. Okay, so they are not giving you directly the family of the curve, whereas they are asking you to first derive the family of the curve equation. So it is asking you to say the write the differential equation of all circles which is touching the x-axis at the origin, right? So let us try to see how you will be actually tackling this kinds of question. Now this is a question which is a very important question, especially for JEE Mains. Okay, so I am taking this question from JEE Mains previous year paper, right? So you can see in multiple shifts there has been a question of this particular type. Instead of x-axis they might give you y-axis at origin, or maybe they might change the question and might give you certain equation of the straight line also, right? So multiple combination of question can be given, but once you understand the basic how to solve the question, I think none of the question will be difficult to solve, right? So let's try to see the solution for this question, right? So first of all, I would request all of you to please let me know that how are you going to formulate the required family of curve equation over here, right? So if I try to understand that how to write the equation of circle touching the x-axis at origin, right? So if I ask you that what is the general equation of circle, right? So if I ask you the general equation of circle with a center at a comma b and the radius as equals to r, right? So with the center at a comma b and the radius equals to r, how am I going to write the general equation of circle? So the general equation of circle can be simply given as x minus a whole square plus y minus b whole square is equals to r square. So this is the general equation of the circle with the center a comma b and the radius is equals to r square, right? So now if I do some try to understand what is this family of curve representing, it is asking me to write the equation of all the circles which is touching the x-axis at the origin, right? So if I try to draw the coordinate axis over here, this is our simple coordinate axis, right? So if it is touching the x-axis at the origin, so it is something form of like this, maybe something like this, right? So I can have multiple combination of such circles, right? So this is all what is known as the family of circles, right? Family of circles, right? So this is a family of circles, right? So therefore we will try to derive the equation of the family of circle first, and then we will go on to develop the differential equation from it, right? So if I ask you that since all these circles are touching the x-axis at the origin, right? So origin is 0 comma 0, so at this origin it is touching it, so all the centroid or the center of the circles are definitely going to lie on the y-axis. So I can make a statement over here, the center of all these circles, the center of all these circles lie on the y-axis, right? So I can make this statement that the center of the circle is lying on the y-axis, and let us take any variable point b, right? So the center of any of the circles is given in term of 0 comma b, where b is any real number, right? So where b is any real number, and I can vary the b to get multiple centers of these given different vary circles over here, right? So now from this particular thing, and also let us say the radius is r, right? Let us also assume the radius is r, right? So therefore, once I have these two information, I can formulate the equation of circle. So the equation of family of circles can be simply now given as, can be simply from here given as x square, because x minus 0 square, that is x square, plus y minus b whole square is equals to r square, right? Is equals to r square. Now if you look at this particular equation, now this is the equation of the family of curves, right? Now this is the equation of the family of curve. Now once you have this particular equation as a family of curve, now the first step is to identify what are the number of unknowns, right? So if I try to observe, and one more thing to interesting over here is that if you try to see the radius, now many students will come and tell me that there are two arbitrary constants, right? So if I ask you how many arbitrary constants are present over here, people will definitely tell me the answer as 2. But I would say, please look carefully. This is not equal to 2, because b, the unknown b and the unknown r are related by a simple algebra, right? So if you look at this any of the circles over here, what you observe is that now general principle of circle is that if any line is at touching the circle, that is a tangent, and if you drop a perpendicular from the center to the tangent, this particular distance is equals to the radius, right? So the distance of the center and the point of contact of the tangent is equal to the radius. So therefore from here I will observe like my radius is equals to simply equals to b, that my radius is simply equal to b, right? So that is a very cunning observation over here. So from here I will be writing that my radius is equals to b, right? So therefore my equation of the circle will be modified as x square plus y minus b whole square is equals to b square, right? And therefore I can simplify this equation, that is x square plus y square minus 2by is equals to 0. I hope this is correct, right? So this is our final equation of the circle, right? Or the family of circles. So from here, what we understand is that, what we try to understand is that, now this is the general equation of the family of curve, right? Now, if you observe that how many arbitrary constants are present, you will see that there is only one arbitrary constant, right? So there is only one arbitrary constant. So if an arbitrary constant is equals to 1, so you will be noticing that that order of the differential equation which you are trying to form will always be equal to 1. That means you have to differentiate this particular equation of the family of circle one time, right? So if I do that particular step over here, so if I differentiate, if I differentiate this equation one time, okay. So if I differentiate this equation one time, what I'm going to get? So I'm going to get differentiation of x square is going to be 2x plus 2y dy by dx minus minus 2 times of b dy by dx is equals to 0, right? So this is something that I am going to get if I differentiate this following equation one time with respect to x. Okay, so please note I am differentiating with respect to x. Okay, so differentiating with respect to x one time, I am going to get the following relation. Now from here it is very easy to eliminate the constant b. So from here what I am going to do is that I am going to club dy by dx, and this is basically 2 times is equals to y minus b is equals to minus of 2x. So from here 2 and 2 got cancelled, and therefore I will have dy by dx into y minus b is equals to minus of x, is equals to minus of x. Now our arbitrary constant is b, so therefore if I try to represent b, so from here I can write b as equals to, so please check the algebra, b will be equals to x plus y, because I'm replacing this with y minus b with b minus y, right? So it is going to be x plus y dy by dx, x plus y dy by dx whole divided by dy by dx whole divided by dy by dx. So that is going to be the value of the arbitrary constant, right? And now if I substitute this arbitrary constant in the required family of equation of the curve, then I'm going to get the required differential equation. So therefore from this particular part over here, my required differential equation is going to be looking like x square plus y square minus 2 times of this big expression, right? And y is equals to 0. So this is our required differential equation. So from this formulation of the family of curve, I can now get to the differential equation. Okay, is this clear? Is this clear to all of you? Hi Nikhil, one shot revision लेकर आना भाई. Yes, sure. निखिल, definitely वो आने वाला है, ठीक है? Definitely the one shot revision lectures, especially before your JEE Mains and Advanced examination, is definitely going to be there in the channel. First of all, please subscribe to the channel and follow the channel regularly, okay? If you are suddenly coming and watching these contents, then definitely it is not going to help you a lot, okay? So please subscribe to the channel, please hit the bell icon so that whenever we are live, you get a notification on your mobile, right? So please keep on following their contents regularly, then only will be understanding everything, right? So this particular lecture series is basically going to be more in detail, where I am covering each and every topics of maths one by one, right? And apart from maths, you can also see that there are physics lectures also coming up and chemistry lectures also coming up. And students who are preparing for NEET examination, we do also have a separate channel for NEET aspirants, right? So you can see the biology lectures are also being uploaded on that particular NEET channel. Okay, so please follow those contents and definitely you can come up with the definitely good amount of preparation. Okay, so keep on doing these particular things and please subscribe to the channel and also hit the bell icon and keep on watching the content regularly. Okay, so whenever the video is live, you get a notification and attend the classes. Okay, is that clear, Nikhil? Okay, so focus on the class first of all. Please focus on the class. Is this clear to all of you, right? Now, now we understand over here that from a given family of curve, I can able to get to the differential equation, right? So the formulation of differential equation is the most easiest step, right? But to arrive to the inverse of it, to arrive to the family of curve from this differential equation is the difficult step, right? Because most of the formulation is not in terms of the family of curve. In generally, if you look at any general problem of nature, any general problem of nature, what you're going to observe is that you will be definitely able to write the equation of the any of the equation in differential form, and that will be related by a differential equation, right? So from getting the differential equation to find the analytical solution of the unknown in terms of the known criteria, that will be the most important part that we need to do. And I have already explained you that how that particular differential equation comes up, right? Especially taking an example of physics also, right? So please watch the previous lecture before you are watching this particular session. So today our job is to look into the solution. Okay, our job is to look into the solution of this differential equation, right? So I will try to help you out how we can go and get to the solution of the given differential equation from this particular case, right? So let's try to see the first form of solving any easy solution of a differential equation, and that is something also known as variable separable form, right? So once we know how to form the differential equation, now our task is go to solving the differential equation, right? So let's start our today's topic, that is solution of differential equation. Okay, so now I'm going to discuss about the solution of differential equation. Okay, so solution of differential equation, and I'm going to start with the very first method, that is variable separable form. Okay, or I can write variable separable form. Okay, so let's try to understand what does variable separable forms actually refer to, right? Now, if we look into the differential equation, the solution of the differential equation is a relation between the variable of the equation not containing the derivative, right? So, if you look into this similar differential equation over here, you can see the unknown is y and the known is x, right? So, you have to get to the solution of y which does not contain the terms like the derivative terms, right? So, it will only contain some arbitrary terms and the x terms, right? That is basically to get to the family of curve equation, right? So, if I give you a simple example, let's say I have a simple, very simple differential equation, right? Let us say dy by dx is equals to e to the power x, right? Now, if I need to find out the solution of the differential equation, what do I actually mean is that I need to write the value of this unknown in terms of only function of x, in terms of only function of x, and that will actually refer to my solution, right? So, that will actually refer to my solution, right? Now, in order to solve this, what are the different methods to solve this, right? Now, if you recall that in integration, what did we understand? Integration is basically defined as the reverse process of differentiation, right? So, over here also, if we try to do the integration by changing the variate, then will be definitely getting to the final solution, right? So, that is our main primary idea, right? So, from this differential equation we have over here, if I write this equation in form of a something called as variable separable form, right? What do I mean by variable separable form? That is, see over here, the function that is present on the right hand side is a function of x, right? So, and the derivative, that is dy by dx, right? So, x is present in the denominator. So, what if I compose this derivative and write it something like e to the power x into dx? So, if I write something like this, that is e to the power x into dx, what I am doing is specifically is that I am clubbing the derivative dx term with the function of x, right? So, in doing so, what I can do is that now if I integrate both this side, now we have the integrands over here, and we can definitely perform the integration very easily, right? So, if I perform this integration, the left hand side will definitely give me y, and the right hand side will definitely give me e to the power x, because we know that integration of e to the power x is also going to be equal to e to the power x. But I will also have one more constant over here, right? So this constant is basically denoting the fact that it is basically the family, representing the family of such curves which having like form of e to the power x plus c, right? So on varying the c, you will have multiple family of exponential curves, right? So that is the basic understanding, that from a differential equation, so this is our differential equation. So from this differential equation, I get to the solution, and the solution is basically the family of curve. Okay, so if you recall in my lectures of indefinite integrals, I have already explained to you that what does actually indefinite integrals refer to. So indefinite integral refer to basically a solution of a differential equation, right? That is basically a family of curve, right? Is that clear to all of you? Is this part clear to all of you? We can solve multiple questions now on basis of this, and we can see that how we can separate the variables and get to the final solution of the given differential equation, right? Is this clear to all of you? Okay, so let's try to see that how we are going to solve the questions of the differential equation of first order and 1 degree, right? So we'll only solve question having the order of the differential equation as 1 and the degree is equals to 1. Okay, that is very important to understand. So if I take any general differential equation of the form dy by dx is equals to some function of x comma y, what you have to do is that you have to separate this function in form of some function of x multiplied with some function of y, right? So if you do that, so you are able to transpose, or you are able to separate this function in form of some variable separable form where the x is separated and the y is separated, right? So once you do this expression, the steps to follow is over here is that then you will write that dy upon the function of y is equals to dx and the function of x, right? And then you have to perform the integration with respect to the following integrants, right? So now if you perform the derivative or integration, sorry. So now if you perform this integration over here, you will get to the required solution. You will get to the required solution, right? So let me write in terms of some other function. Let us say it is capital F of x, right? So then I will get to the solution, right? So this is the general procedure. So from the given differential equation, you have to separate the variable and try to express in this particular form of the integration, and then from integration we'll get to the solution, right? I hope the steps are clear, right? So this is a basic step that we need to follow in variable separable form, right? So now I will take up multiple examples to explain you that how you can actually solve these questions of variable separable form. But before that, please let me know in the live chat, is this part clear to all of you? Is this part clear? Are you all able to understand the concept that I'm trying to explain? Is this part clear to all of you? Yes or no? Please let me know in the live chat, yes or no. Okay, so we will now go about solving some questions, okay, and we'll try to understand how we can arrive to the solution from a given required differential equation by using the simple formation of variable separable form, right? So let me take a simple question to start with, right? So the very first question that I'm going to start from here is that, let's say I have to solve the given differential equation as follows. So I have a differential equation secant square x, and then I will have secant square x into tan of y dx plus secant square y into tan of x dy is equal to 0, right? So this is our required differential equation, right? So what if first of all, let's try to express it in the dy by dx form, right? So if I club and write the terms in dy by dx form, so if I do that, so dy by dx, so if I try to club the dy by dx form terms, then I'm going to get it as secant square y into tan x plus secant square x into tan y is equal to 0, right? So this is our required form of differential equation, right? Now I already explained that what is your next step. Your next step is to separate the y with the dy term and the x with the dx term, right? So if I do it over here, then with dy, so if I do it over here, so I will get secant y divided by secant square y divided by tan y into dy is equals to secant square x divided by tan x. So then I will get this form over here, and a minus sign is there, right? Now I have to just integrate both these sides. Now I have to integrate both these sides to get to the solution. So it is very simple. Now if you assume tan y as t, then secant square y dy is going to be dt. Therefore, the solution is natural log of mod of y plus natural log of mod of tan of x is equals to some constant c, right? Now what we know that if the base of the log is same, that is e, so over here then I can, the log a plus log b is going to be log a into b with a common base. So this is going to be equals to natural log of tan x into tan y is equals to some another constants is equal to some constant c, right? Now from this particular thing we can write the required value, that is tan y into tan x mod of it is going to be equal to e to the power that constant c, right? Now we already know that exponential function is always going to be positive, so the mod has no significance over here, and therefore I can write this term tan y is equals to e to the power c divided by tan of x, right? Now therefore from this particular form I can write y is equal to tan inverse of e to the power c divided by tan x, right? So this will be the required form of the solution of the family of curve, right? So therefore, for the given differential equation we have, the solution to this question is going to be like this over here. I hope this is clear, right? So this is the solution of the required differential equation. So therefore, the solution basically refer to the family of curve, right? I hope this step is clear. Now, why I am telling you the family of curve? Because I am unknown the value of C, right? Now, if I give you a certain condition, that is the initial value problem, that is, if I give you that at x equal to 0, the value of y is equal to 0, like that particular constant, right? So, if I give you that particular condition that at the value of x equal to something, the value of y is this particular thing, then only I'm able to get to the value of the constant, right? So this will replace the value of the constant c over here, and ultimately I will get to the particular solution. This solution is a general solution or the general solution of the family of curve. But in order to get a particular solution of the curve, I need some condition that is also known as the initial value problem or the boundary value problem, right? So I hope this is clear. Now, for one order or first order differential equation, we definitely need only one condition, right? So that will be generally classified as an initial value problem only. Okay. Is this clear to all of you? Is this step clear to all of you? Please let me know in the live chat. Please let me know in the live chat. Is this step clear? Is this part clear to all of you? See, thumbnail, I don't make my thumbnails, okay? That is, the team is working on thumbnails things, and the team is basically responsible for the thumbnail. Okay, but I will let the team know the thumbnail is basically, you didn't like the thumbnail, that's something your concern, right? Anyways, please focus on the content, okay? Thumbnails and all those things are secondary things, okay? They don't even matter, okay? Please try to focus on the scientific things, otherwise, anyways, you are definitely going to actually prepare for some exams, right? So focus on the relevant things and just ignore the other things, okay? That is something of good advice, okay? And I know people are random people's coming up on the YouTube. I know that is the worst thing, and India is also full of this brain rot peoples. So yeah, anyways, so any questions on this particular scientific questions, any scientific questions or any concerns over this mathematics topics? If you have any questions over this concern or steps over here, or you are not able to understand some of the steps, please let me know. I can help you out with the steps, okay? All the secondary things are not relevant in this class, okay? Is this clear to all of you? Please let me know. Is this solution clear to all of you? So if this solution is clear, then please try to solve this problem, right? Please try to solve this problem. Now, let us say I have a differential equation. Let us say I have a differential equation which is given as square root of 1 plus x square plus y square plus x square y square is equals to plus xy dy by dx is equals to 0, right? So if I have this formulation of a given differential equation, right? So please try to solve this differential equation. Please try to get to the solution. Please try to do it by variable separable form, right? And you can see that easily it will be simplified in terms of variable separable form, right? So please try to solve this question and then perform the integration and let me know the solution. Please try to solve this question. Please try to solve this question. Please try to solve this question, okay? And let me know the solution in the live chat. Right? Any ideas? Any suggestions? How can we solve this question? Anyone? Anyone having any suggestion how we can solve this question? Yes, no, anything? So first of all, if you look and carefully in this question, what you can see that this particular square root term can be combined as, so 1 plus x squared plus, now if I take y square as common, this can be written as 1 plus x squared again, right? And then we have xy dy by dx, right? Which is equals to 0, right? So what I see over here, that is I can combine and I can write it in terms of product form, that I can write these terms as square root of 1 plus x squared multiplied with 1 plus y square, right? And which will be equal to minus of xy into dy by dx, right? Now as we can see that we have almost separated the variables out, right? We have separated the two variables in different forms, right? Now once we have separated the form, we can simply apply the variable separable form. What can we do over here now is that I can write the rest of the part as square root of 1 plus x squared whole divided by x plus y upon square root of 1 plus y square, and we will have dy and we will have dx with this and equals to 0. Is this step clear to all of you? This is the simple variable separable step, right? So this is the also known as the variable separable step. Now once we do this step, then the solution of the differential equation is simply given by the integration. So now we can perform the integration on both the sides, okay? Now you might ask a question, integration of 0, right? It is 0 over here. So how we can perform the integration? It is not like that. You can take these terms on the right hand and the left hand side, and instead of writing 0, we can club and write this term as, so equals to minus of this, right? It's the same thing, right? So then we can perform the integration over here, and if we do the integration of this particular term is going to be, we can perform this integration by simply applying the by parts. So therefore the integration I'm writing over here, so if I do this integration by parts, so first of all this is the first term, and plus 1 by 2 natural log of square root of 1 plus x square 1 plus x square minus of 1 whole divided by square root of 1 plus x square plus of 1, right? which is equals to now here it is easy, that is we can again it is very simple, right? So we can assume 1 plus x square as some variable t. Similarly we can assume 1 plus y square as some variable t, and we can perform this integration, right? Similarly on the right hand side we are going to get the relation as this particular part will be 1 upon square root of some variable, so that will be simply given out by square root of 1 plus y square plus some constant c, right? So this is basically taken out from the integration. So if you perform the integration, now I know you might have difficulty to get to the solution, right? So for that I will tell you, please refer to my previous lectures, okay? Please refer to the lectures on the indefinite integral, okay? So please go back to the channel, please check out the playlist on the channel. You will find multiple lectures that has been taken so far, right? So please watch the contents on the indefinite integral to find out how we get to this particular step over here, right? So if you just do one step of substitution and then we perform the integration, you will definitely get to the solution, right? So ultimately, the solution of the differential equation is basically of this particular form. I hope this is clear to all of you. So this is my required solution of the differential equation. Is this clear? Is this clear to all of you? Did anybody of you try to solve this question? Did anybody try to solve this question? Please let me know in the live chat. Is this part clear to all of you? Is this part clear? Is this part clear to all of you? Is this part clear? Okay, so since you're not replying anything, so I think it is clear to all of you, right? So once this particular part is clear, now our next step is to go towards seeing how we can solve differential equation which is not directly given in form of a variable separable form, but we can definitely reduce it to variable separable form, or that is also known as the reducible to variable separable form. Okay, so that will be the scope or the content for our next class. So please subscribe to the channel and hit the bell icon. And before we end the class, I want to give you some homework problem to actually practice on this particular type of variable separable form, right? I don't want to hurry up and finish the syllabus in one go, but I want to actually give you some time to understand these topics and we can go on understanding step by step, right? So please try to solve these few questions by using the variable separable form. So first homework problem is solve the required differential equation Okay, so please try to solve this first problem. Okay, please write it down. Please write the homework problems down. Okay, this is the first problem. And the second problem is e to the power dy by dx is given as some x plus 1. Okay, so please try to solve this problem as well. Okay, so these are the two homework problems that I definitely want to give all of you, and try to solve these questions and definitely come up with a solution in the next class. Okay, so please let me know the answer to these questions in the next class, or maybe you can write down the answer to these questions in the comment section. Okay, so we are definitely going to have class again tomorrow, and definitely you're going to see the live classes again tomorrow. Okay, so please hit the bell icon so that whenever the class is live, you definitely get the notification. Okay, so please hit the bell icon and also subscribe to the channel, and definitely share this video among your friends and your relatives or anyone who is preparing for JEE Mains and Advanced examination and definitely lack proper coaching money, right? So we are not charging any money for giving you relevant content. Okay, the coaching classes, they will definitely do a lot of promotions and lot of things. They will ask you to give hefty fees, taxes and all those things, and definitely you will end up getting nothing. Okay, whereas by sitting at a comfort of your home, you can definitely tune into your YouTube channel, and definitely you can watch the lectures at the comfort of by sitting at your home or by relaxing in your couch. You can definitely watch these lectures, right? So please hit the subscribe button. That is one kind of commitment that I'm asking to all of you. And also, if you like this video, please hit the like button, and also share these videos among your friends, your relatives, and whomever you feel that this particular content is going to definitely going to help them, right? Because these are already on free for YouTube, right? And we are definitely trying to help you out in with giving certain relevant contents by helping out with the detailed understanding or detailed step-by-step derivations, right? So I hope this will help you up in your long-term studies. And with this part, I would conclude the session over here. So thanks all of you for your definite concentration in this lecture, and we hope to see you soon in our live class again, right? So with this, thank you and all the best. Bye bye.